What I'm going to do in this video is I'm going to talk about separation techniques we covered in the last couple of videos, such as distillation and crystallization, and how we can use those separation techniques to be able to make very useful substances or products. And one example would be oil. So you've probably seen these barrels before, and these barrels are just your normal regular oil, crude oil. So it's called crude oil, and it's not going to be very useful by itself. The good thing is we can make these crude oils, we can make it into different substances. So for example, petrol. I'm sure you've heard petrol before. Petrol is to fuel cars, and we can also make it into natural gas, which is there to warm our homes. And we can make crude oil also into, for example, plastics, which we rely on a daily basis, and rubber. And crude oil is actually the main source at the moment of plastics and rubber. So how do we do that? Well, we do that through a process called distillation. And remember, distillation was the idea where we have a substance, in this case crude oil, and we heat it until it becomes a gas. So here we put crude oil in here, and it will go into a furnace. Now, furnace basically is just an oven, a very hot temperature. So it's going to provide our heat. And it's going to allow us to be able to evaporate that oil. So the oil will be evaporated, and it will be in its gaseous form. And it will go up this chimney-like container as a gas. And any of that gas that escapes, for example here, will be condensed and turned into fuel. Any gas that escapes up here will condense or be made into natural gas. Any gas that escapes here will be condensed, which means it will be cooled, and it will be petrol. So we can use distillation, which was the idea of, again, heating a substance, then that evaporated gas goes up and cools at different places, and where it can cool, it will result in different types of products being formed, and some of them were petrol, natural gas, or rubber. This is how we can use distillation to produce extremely many useful substances. Also, we can use something called magnetic separation to be able to, for example, produce iron, right? Separation. Now an iron ore, so I've written iron ore here, that's just basically a rock that has bits of iron, but bits of other things we don't need. So this would be here, this would be iron ore, and this is, a bit of it is iron, right? And a bit of it is just different types of other things which we don't want, so mostly rock. So what we do is first we crush this up into very small pieces, this iron ore, and then we bring it down. So this is almost like a conveyor belt. We bring it down. The cool thing is here there's a big magnet right there, and you can imagine anything that's crushed up that is iron will be attracted to the magnet, so it's going to stick. So here you can see all these things that are sticking to the magnet that have been pushed down are going to be iron. So iron here will be basically collected, and anything that's not magnetic, so for example the other rock, that will just fall down and be separated that way. So we end up being able to produce iron using this huge magnet and this huge magnetic separation technique, which gets used in industry a lot. So that's how we produce our iron. We get an iron ore, crush it up, and then we collect the iron from the magnet. Also, we can use seawater, which is basically salt water. So seawater is more or less the same as saying salt water, because there's lots of salt in that water. We can use it to produce salt. The way we do that is we let seawater come into a pond or just a small collection area, and remember that water is going to be mostly water but also the salt, and then we let the sun use the heat from the sun to evaporate the water. Remember, that's called crystallization, right? So evaporation plus crystallization. And at the end, so at the end of this whole procedure, what we have left after all the water has been evaporated, it's just the salt. So you can see here all of these salt piles. This is how we produce the salt. Much of the salt that you use on a daily basis, table salt, is often called sea salt because it actually comes from the sea. And this is how we make it. We just get the ocean water to come in, evaporate the water, and then we have the salt left over afterwards. Another cool thing we can do is river water is often quite polluted. There might be different types of pathogens, bacteria in it, but also there's going to be lots of soil. And that soil or that sand is going to be suspended, right? It's not going to be dissolved. It's going to be suspended. It's going to be floating in the actual water. But if we let it go into huge containers, so this is the river water, it's going to go through different processes, and then we're going to let it stand for a while, And remember, anything that's suspended, what it will happen eventually, the suspended particles, in this case the solid particles, will drop to the bottom, and then we call it sediment. And then all we have to do is we have to open that area, and we can just remove that soil and clean the water. So river water is often water we drink, but beforehand we declean it, because we can do that through this separation technique, right? Which is called sedimentation, when we let the sediment, which is soil, collect on the bottom, then open basically a opening, and then we just collect it, and we can use it for compost as an example, which helps grow trees again. Right? So these are 4 separation techniques: distillation, sedimentation, crystallization, and magnetic separation, that can be used for actually really important processes. These are just 4 examples, but I could go into way more. But it'd be really good to know at least 2 or 3 of these and be able to just kind of explain how they would work as well.